Solve the following equation for x. So our equation is e to the power of x minus 5e to the power of negative x equals 4. And now to start off with, we're going to express all of the powers as positive powers. So what we can do is we can write this as e to the power of x minus 5 divided by e to the x, because this negative power here means we can make it a positive power by moving it to the bottom line of a fraction. And then all of that is going to equal 4. And now to help reveal a pattern that might exist in this equation, we're going to let a equal e to the power of x. Therefore, our equation becomes a minus 5 divided by a is equal to 4. And now whenever we solve equations by hand, one of the things we generally like to do is have all the pronumerals on the one line. So I'm going to multiply every term by a, and this will give us a squared minus 5, because we have minus 5 on a times a is just minus 5, is equal to 4a. Now hopefully you can recognise that this is a quadratic that was hidden in our original exponential equation. So when we solve quadratics, we like to get one side equal to 0 and then factorise. So what we're going to do is we're going to subtract 4a from both sides of the equation. And this is going to give us a squared minus 4a minus 5 equals 0. So inspecting the equation that we now have, we can factorise this by inspection. So we're going to have two factors multiplied together still equal to 0. And we can see that this is going to be a minus 5 and a plus 1 as the linear factors. So using the null factor law, we can say that a minus 5 could equal 0, or we could have a plus 1 equaling 0. Solving the first equation, we add 5 to both sides to get a by itself, and that gives a is equal to 5. And for our second part, we're going to subtract 1 from both sides, and this will give a equals negative 1. However, we knew that capital A equals e to the power of x, so we're going to substitute that back in. So we say that e to the power of x could equal 5, or e to the power of x could equal negative 1. And we can now use an equivalent log statement to find the values of x. So for this first part, we're going to have log e of 5 is equal to x. And taking an equivalent log statement of the second part, we have log e of negative 1 could equal x. However, logs are not defined when the part inside the log is negative, so this is undefined, meaning that the only solution to this equation is x equals log e of 5.